Okay, let's have a look at this question 9. This is question that has to do with triangles, so page 16. As well, we're going to do ratio or conversion. We're going to be looking at distance, time, and speed, trigonometric function, and derivative of it. So really packed question. An aeroplane fly east from point A for 2 hours at a constant speed of 240 kilometers per hour. So from A, it's flying at a constant speed. Until it reaches point B. So from A to B, the speed here is 450 kilometers per hour, and it takes him 2 hours. It then changes direction by heading 20 degrees towards the south at the same speed. So here, and that's why we are saying 20 degrees, that's where that 20 is, until it reaches point C, as shown in the diagram below. The direct distance from A to C is 1,450 kilometers and angle BAC 8.57, and we have all those information here. So we have to find out how long it takes to fly from B to C. So this distance, that's what we have to find out, and we have to give our answer correct to the nearest minute. So let's get our triangle and let's see how we're going to solve that. So all our question with triangle, how do we solve? Page 16 in our table. So we are saying page 16. Well, let's put the information that we know. So here it takes 2 hours to fly and the speed is 420 kilometers per hour. This is the side we are looking for. So page 16, we know, divided to two main parts, right angle triangle and not a right angle triangle. So that's always the first question that we ask ourselves. On the right angle, we have Pythagoras trigonometric ratio, and not right angle triangle, we have sine rule and cosine rule. Pythagoras formula involved 3 sides of triangle. Trigonometric ratio doesn't matter which of them, 2 sides and an angle. Sine rule, 2 sides, 2 angle, and cosine rule, 3 sides and an angle. If you are not familiar with that, have a look at the video on the basic knowledge that has to when I'm explaining how page 16 works and in how do we use that in questions with triangle. So we ask ourselves always a question, is it right angle? We are dealing here on not a right angle, and obviously this is not a right angle triangle. So here, like I said, we have 2 options. Now we always start from what we are looking for. We are looking for a side, so side has to be included. We have another side, okay, 1 for 50. Now we do have information about the third side. The question is, can we find the length? Maybe we could work that out. What else do we have? We have an angle 857, and then we have an angle, and then we have an angle here. Now, can that help us to find the angle in triangle? Well, obviously yes, because all of that is 180. So from 180, if I take away 20, that will be 160. Let's just mark that in green, 160. So actually, yes, we do have another angle. And yes, here we could consider that we could consider cosine rule, but I'm thinking, well, sine rule, we kind of have everything hopefully that we need. So let's get our formula from the table for the sine rule. So like I said, page 16. Let's get our formulas in. So in order to use this formula, we need to know what is A, B, and C in our own triangle. We always start with angles. So if that's angle, let's say that's my A, therefore what side opposite will be A. If that's my angle B, therefore the side opposite will be B. And then if that's C, therefore the side opposite is going to be C. So I'm saying, okay, what information I have? Because though there are 3 fractions, we are only using 2 out of 3. Obviously, we don't solve a question that has two equal sign. So B is the one we are looking for. So that's our question mark. C, capital C, we don't have. We don't have the small c. Do we have capital B? Yes, we do. Do we have capital A? Yes. And then small a? Yes. So we know that's the one we're going to consider. Now, you can be thinking, well, we could actually find, and yes, you are very right, I could find the value of C. How will I find the value of C? All angle in triangle add up to 180, so I could find this angle by taking away those two from 180. Then here could, like, let's just consider for a moment, could I find this length? Yes, because I don't know if you remember that formula with speed and time and distance. We don't have a distance here. However, what we have, the time it took and a speed. So those two multiply will give me the distance. So if I multiply 2 hours by 420 kilometers per hour, I'm going to get my distance. So yes, actually, so I could consider cosine rule as well. But we said sine rule, let's go with sine rule. So let's put those values in. So A, 1450 divided by sin of A, which is 160, and that equal B, that's our BC we are looking for, over sin of B, and sin of B is 8.57. Now, fraction equal fraction, how do we solve it? We can cross multiply it, or we can look at it different way. I want BC, that should be B, not D. BC on its own number on the other side. So the denominator has to go that number here. How do we eliminate denominator? We multiply, and we multiply both sides of the equation. I'm missing 8, sorry. So why do we multiply? Because sin of 8.57 divided by sin of 8.57 will equal 1. 1 multiplied by BC will be BC. So that means this side of the equation we have sin of 8.57 multiplied by 1450 divided by sin of 160, and that equal BC, the one we are looking for. So let's put that in our calculator. So sin of 8.57, close bracket, multiply 1450, and then divided by sin of 60, not 60, 160. And we get our BC, BC equal 631.7626. Let's look at the terms and condition of our answer. Oh, I apologize, didn't read well, and I'm always telling you to read. We actually have to not find length from B to C, but it's how long it took. Okay, so this is how far they went. How will I do how long it took? Well, using this formula, isn't it? So again, I'm looking for time, therefore that means it will be distance divided by speed. So my time will equal distance, we just found 631.7626 kilometers divided by speed. And here we are told in the question that it changes the direction by heading 20 degrees towards the south at the same speed. So what's the speed? 420 kilometers per hour. 420 kilometers per hour. So we divide our value 631.7626 divided by 420. So 1.50 of an hour. And now let's check the terms and conditions. Give your answer correct to the nearest minute. So 1 hour, and let's check how much is 0.5 of 60. 0.5 of 60. 30, so 1 hour and 30 minutes. Yeah, why? Because we know that minutes are not in hundreds, they are in 60s. So so that's why we have to multiply decimal by the value of 60. Okay, so that's part 1 done. The average fuel consumption of the plane is 3.8 liters per second. So they are saying that's how much fuel it consumes. every 1 second 3.8 liters. And the fuel capacity of the plane is 100,000 liters. Okay, so this is how much liters of fuel it can hold. Show that the plane will be able to complete the journey from A to B to C and directly back to A at a speed of 420 kilometers without refueling. So what is that we are looking at? They are telling us the details about how does the plane have the consumption of fuel. And then they are saying, well, check whether it will be able to do the flight. So how am I going to do that? Well, if you think about it, so we are saying that will it be enough fuel for him to fly all this distance? We know how much he's using fuel. We are told that 3.8 liters every 1 second. So I'm saying to myself, if I know how many seconds, because let's keep it with seconds or change it to hours or minutes, whatever we want. But let's say if I know how many seconds it will take the plane to fly all that distance, well, then I will be able to determine how many liters of fuel he needs, isn't it? So I need to know, in order to, then once I know how many liters of fuel it needs, well, then I will see whether he has enough. So I'm saying, okay, I need to know how long it took him to fly. So we are told from A to B that it was 2 hours. Now from B to C, we just find out that was 1 hour and 30 minutes. And all we are missing is C to A. How long did it took him to fly that? What do we know about A to C? We know that the distance here is 1,450 kilometers. What else do we know about? Okay, sorry, I'm just reading here. So at a speed of 450 throughout. So we know that the speed is 450 kilometers per hour. So we are looking for time. Therefore, again, our formula, and this formula is not in your table, so you need to know it. So if I'm looking for time, that means I'm dividing distance by speed. Here you always have to be mindful of the measurement. The distance is 1 for 50 kilometers. And the speed 450, not 450, my bad. I can see I didn't write that correctly. That should be 420. And then I will be wondering why my numbers are going wrong. 420 kilometers per hour. So let's see what time into 1450 divided by 420. So that is 3.45. So again, just to have everything, so 3 hours 45 multiplied by 60, that will be and 27 minutes. So he's flying 2 hours, 1 hour and 3 hours, so that's 6 hours and 30 minutes and 27 minutes, 57 minutes. So the question is, 100 liters that he has, how long will it last him? So that's the question we can ask. So we are saying 100,000 liters. Well, how many seconds will that give? And then we can see whether that seconds will be at least, let's say 7 hours, let that 3 minutes of the delay, So, so let's see. So how do we solve it? This is what called conversion, ratio, proportion, any way you want to call it. The idea is here that in order for it to work, and we can use it to convert anything, is we have to have the like things on the same side, yeah? Seconds, liters. And then we cross multiply it basically. So x multiplied by 3.8, that will equal 1000 multiplied by 1, which will be 100,000. You ask me, well, do we always go this way? I could go the other way around. I could say 100,000 multiplied by 1 equal x multiplied by 3.8. Doesn't matter, as you can see, it's the same thing. So to find the value of x, we need to eliminate that number. It's a multiplication. How do we eliminate it? Always the same. We divide, and we divide both sides of equation. So 100,000 divided by 3.8. 26,315 seconds. That's how much. Okay, so how many hours is that? Just remove that here. So if I want to find out how many minutes, what do? I take that number and I divide by 60, isn't it? So that gives me 438 minutes. Now again, if I want hours, what do? I divide that again by 60 to give me the number of hours. 7.3, so 7 hours and a bit, isn't it? So yes, the plane can do that because that's how much fuel it has, more than 7 liters, and for the more than 7 hours of a flight, and he need a bit less than 7 hours of a flight. Okay, now let's have a look at next part. Now part B, very different part, nothing to do with part A. So the voltage, VT in volts, of a certain alternating current is given by the function. And here we have trigonometric sine function. Now, before we go on with solving anything, if you have a trigonometric function question like cos or sine, I would advise always, as a good practice, to do quickly a small sketch of the graph, because if we do the graph, the small sketch of the graph of the function, we will have a better idea to reply all the question. So let's remember how our trigonometric questions or functions are built. So the first number, or the number that stands beside cos or sine, that's the amplitude. Oh, I misspelled that. Forgive me, because I'm not teaching English. Amplitude. That's the amplitude. Then after that will follow cos or sine, and after that will follow our variable x, and sometimes with additional number standing beside our variable, and then we have plus additional number, and that's the midline. So let's remember what's midline and amplitude. Midline is the line in the middle of our function. That's what it is. Amplitude, this is how far from the middle of the function it will go up and it will go down. What I mean, if I have any function like that, here will be the middle of it, that will be the midline. So whatever that value here is, let's say if that value is 5, here we're going to have 5. And then how far it will go from the midline to those amplitudes, to those peaks, well, that's the value of the amplitude. Let's say it will go up 3. So here I'm going to have 8, and here I'm going to have actually 3. That's not accurate because he's below. Doesn't matter, I'm just doing the drawing. So that means here I would have 3. Okay, second thing that we need to remember is the formula on what's with my misspellings today? Period. We need to know how to calculate the period. Is 2 pi divided by c, c being that number that stands beside x. Okay, so let's remove that because that's just to explain what's the midline and what's the amplitude. Now let's consider our function that we have at hand to identify. So the number that stands beside sin is that number here. That will be my amplitude. Now, there is no number, either additional number plus or minus in the front, so therefore that doesn't have a midline. Midline is 0. That means that the x-axis, that's where we have 0. That's what will be our midline. And then that's our variable t, and that value here, that's my c. So when we are doing a sketch of our function, so we know that's going to be a midline. Now, sine function starts from the middle. So we're going to be starting here. That's our midline. So our function is going to go up and it's going to go down and up again and down again. But before we do that, let's remove that. We need values to go around that. So the amplitude. So from midline, it will go up this value. So because our midline is 0, therefore here I'm going to have 110 square root of 2, and it will go the same value down. So here will be minus 110 square root of 2. Now, the period. Sine and cos function and tan, but sine and cos function are very symmetrical. Okay, so therefore, if I find the period of this function, and period would be 2 pi divided, what's the c? 120 pi. So 2 pi divided by, well, I don't have to do that. I can actually do that in the calculator. 2 pi divided by 120 pi. Oh, not that pi. So 1 over 60. That's our period. Now, that period is going to be divided in 4 equal parts. So let's divide our period in 4 equal parts so that we know how much is one part. So 1 over 24 is each part, 1 over 240. So that will be 2 over 240, 3 over 240, and we know that's 1 over 60. I'm sure maybe those will simplify. 2 divided by 240, 120. 120. Geez, not only me spelling today. 3 divided by 240, 180. But it doesn't matter. We can change them. We don't have to change them. Doesn't matter. All we are doing actually is just going to do a quick graph so we know where our values are. Sin function will start from the bottom. Then it will go up. So exactly here at 1/4 is going to go up. Let's change the color. Then it's going to come down, so exactly again at another 1/4 is going to go down. Then exactly at 1/4 will come down here, so that's where it's going to be, and again is going to be here. So our function that's the way it's going to look. So again, what do I need when I'm starting? I need to mark 3 points on the y-axis, midline, and then plus amplitude, minus amplitude. And then I calculate the period and divide that period into 4 equal parts. And sine function starts in the middle, goes up, middle again, down again, and middle again. That's the way the sine function will be. So now that we have it, okay, let's see what are the questions. So the first one is saying, well, there you go. Find the period and the range of the function. So the period we know, 1 over 60. What is the range? From minus 110 square root of 2 to 110 square root of 2. So period 1 over 60 and the range from minus 110 square root of 2 to plus 110 square root of 2. That's the way we write our range. So period and range done. Sketch the function from 0 to p, where p is the period. Indicate the period and the range of the function of your graph. We've done the graph, so that is here range, and that's here is period. So there it is. We've done the graph. Use VT to find the voltage when t is 6.67 seconds. Give your answer correct to 2 decimal place. So use this to find what? This value when t equals 6.67. That's simple enough. We just take our function and we are saying we are finding the value of v when t is 6.67. That means will be 110 square root of 2 multiplied by sin bracket 120 pi multiply by 667. By the way, here is multiplication sign and here, not here. So let's find out 110 square root of 2 multiplied by sin 120 multiplied by pi multiplied by 6.67. So minus 14. Actually, it's not minus 14. That's why the answer surprised me, but I know where is the problem. Do you see that D? It should be R. Why? Because the angle is not in degrees, it's in radians. How do I know it? Because it's expressed with pi. So let's change our angle unit. And there it is, correct answer, 147.95 to 2 decimal place. So 147.95 to 2 decimal place. Okay, let's have a look at next part of this question. So find one value for T where the voltage is 110 volts. Give your answer in the form A over B where A and B belong to N. So we are looking for value of T when volts are 110. So that means 110, let's just check what's 110 square root of 2 to give us an idea, 155. So these values here that we are going is between 155 and minus 155. Here they are saying when the voltage is 110. So I don't know, 110 will be somewhere here. So we're going to have here value and we're going to have here value, isn't it? We're going to have two values. Now, why is that important? Because we're going to solve our equation and we're going to find the value of T. Now that value of T, this is by how much we're going to move from the peak in both directions. That's how we will know how to find this value. So let's do that. So in place of our VT, we are putting 110 and then our equation 110 square root of 2 multiply by sin of 120 pi T. How do we solve it? We want T on its own. So 110 moves to the other side. This is a multiplication. That means we have to divide and divide both sides of equation. So we are left with 110 over 110 square root of 2. And then we have sin 120 pi T. Now, how do we eliminate sin? We take it to the other side and then it becomes inverse, meaning to the power of minus 1. And therefore we are left with 120 pi T. I'm looking for T. What do I have here? Multiplication sign. How do we eliminate multiplication? We divide. And we divide both sides of equation. Okay, so let's see the value we're going to get there. So sin to the power of minus 1, 110 over 110 square root of 2, close the bracket, and over 120 multiplied by pi. So we're getting 1 over 480. That's the value of T. Again, what I'm getting is from this peak, I'm going down minus 1 over 480, and from that side of the peak I am adding plus 480. So let's see what the values. The peak is at what? 1 over 240. That's why I said the graph is so important, because it will really help you solve the question. So 1 over 240 minus 1 480, that will give me one value, and 1 over 240 plus 1 over 480. So let's see, 1 over 240 minus 1 over 480, that will give me actually 1 over 480, so that's one value, and then plus is the second value, so 1 over 60, 1 over 160, that's the second value. Okay, and it is fulfill the condition, fraction a, b belong to natural, top is whole positive, bottom whole positive, and that's what we have. Okay, and the last part, Find the rate of change of the voltage when t equal 2 seconds. Give your answer correct to the nearest unit. When you see the word rate, it's your keyword. What do you think about derivative? Because rate of change is another expression for a derivative. So we have to find the value of derivative when t is 2. So first thing, I need derivative. And when I have derivative, I'm looking for this value when t is 2. How do I do the derivative of my function? Well, always the same. I go to the table and I look for the formulas that will tell me what to do. So my function is sin, and to create a derivative we change that sin to cos. Now obviously we don't have just sin of x, we have a little bit more, and then if we have a little bit more than just x, what happened? We have to multiply by derivative of the bracket. This is basically an application of a chain rule because it's a function within a function. So what happened to 110 multiplied by square root of 2? It just gets carried over in the process of whether we create a derivative or we integrate. And then instead of sin, we write cos. And then whatever we have here that we had here in the bracket, but now we are multiplying by the derivative of that. What's going to be the derivative of that? If I have 3x, what the derivative of that? 3, isn't it? The same thing. We have t, therefore the derivative is a number that stands beside it, so means 120 pi. So that's our derivative, but we want to find the value of it when t equal 2. So we write that again. Now, oops, didn't want to do that. Now I'm not going to write that again. I'm just going to remove t here and put 2 in place of t, and therefore put that in the calculator to find the value of it. Multiply by cos, 120 multiplied by pi multiplied by 2, close bracket, multiply by 120 multiply by pi. Sometimes when you don't put multiplication sign beside the numbers, the calculator will tell you an error. So we have to give it to the nearest unit. So that will go, so 58,646 volts per second. That's because it's V and T volts per second. That is our rate.